We're now going to start our cosmology section of astronomy. We just finished up our space project, Mission Control, and the students did a very nice job on it. So today we're going to go ahead and talk about cosmology. That was one of the missions in the project, and some of the things that were brought up were some of the major theories that some people did not understand. So today we're going to start with the big one, and that is the Big Bang Theory. Of course, the Big Bang Theory was theorized that it was an explosion that created the universe where all energy, matter, and space began. As we take a look at this picture here, an image, we know and we see that, the explosion started, and outward from that explosion, everything started to move away from one another. And as things moved away, the gas and the dust started to collide and form the gravity and form new stars, and new stars formed galaxies, and then these galaxies are ever expanding. And then later on we will talk about what is going to happen after that point. So, what does it say? When the universe was 1/1,000,000,000 of a trillionth of a billionth of a second old, it was the size of a grapefruit. And let's go to the next slide here. Here's some other facts about the theory. For the next million years, the universe continued to expand and cool. Atoms began to form with temperature dropped to a few thousand degrees. Some of the evidence that we see of the Big Bang is background radiation, radiation energy left over from initial explosion that permeates from the entire universe. This is kind of the big thing of where we're seeing that the universe is moving, and this is called the red shift. It's similar to the Doppler effect that you see on the Weather Channel and forecasting the different showers and thunderstorms that will come into the area. The red shift on the electromagnetic spectrum indicates that objects are moving away from itself. So as you can see, as a car, and basically what this is trying to show you here is, let's see if we can get it down there a little bit. What basically we're saying is the car, as the car moves towards you, the sound waves get shorter and get a higher frequency. Therefore, it's louder. But as the car drives away from you, the car has a lower frequency. As we can see from the waves here in the car, the waves are very short at the front end of the car as the car is moving by. But as the car moves away, we see that it gets louder and it gets dimmer and it's a lower frequency. We see this a lot in fire trucks. As a fire truck comes screaming down the road, we hear it nice and loud, but then as it starts to go away, it starts to get very faint in the distance. And that basically is what we see when we see the different galaxies and how they're moving. We see that they are moving away. Alright, let's go back one. So, here's some other quick facts, extra things about the Big Bang that we're going to talk about. At the time of the Big Bang, there was no matter in the universe, only pure energy. Within the first second of the Big Bang, the universal forces appeared. And what are those universal forces? The universal forces are gravity, the attraction of one body toward another. Then we have electromagnetic forces, which binds atoms and molecules together, and it's why electrons are repelled and emits a wide range of wavelengths from the gamma rays to the radio waves. And we've talked about the electromagnetic spectrum before. Then we have the weak nuclear forces that cause radioactive decay. And then the last is the strong nuclear forces that binds the protons and neutrons together to form that atomic nucleus. So as we look at these different forces, we see that we've got, at the time of the Big Bang and this initial explosion, we've got these forces that now appear. Our universe has been expanding since the formation of the Big Bang around 14 billion years ago. And, scientifically speaking, timetables are kind of tough to tell exactly how long or how, but this is the approximated time for the scientists in astronomy that believe in that Big Bang theory. It was recently discovered that the rate of the universal expansion is accelerating. So we recently have discovered that, the universe is accelerating. And later on we're going to talk about the expansion theory, the contraction theory, and the same state theory. And these theories are, how is the universe going to end? And again, like you said, and like I've said before, you can't really tell exactly, because obviously we're not going to be around to see the end. Our solar system was formed within a nebula, the remnants of a supernova. Over billions of years, the spinning eddy created gravity and pulled particles together. The particles collided, forming larger and larger bodies. Planetesimals became planets. The centermost region, where gravity was the greatest, became incredibly dense, creating tremendous pressure that forced the sun, or formed the sun, and that's our only star. So basically, as we see this massive, if I could probably try to get here, insert a blank page here. So if I could try to explain it here by drawing it. All these particles are in space, and all these particles that we see, they start to come together. And so this massive force, and we've talked about it, forms this star. And from that star known as our sun, now what's going to end up happening is it's going to force gravitation, and all these other particles that are rock and dust or on the outer rim, they will start coming together and forming and collecting, and before you know it, you've got an orbit around a star. So all these objects here are going to be orbiting around the star, and you have a solar system. Some scientists believe, if you look at the asteroid belt, it's got all these asteroids all out. Well, in time, could those asteroids collect together and form a planet? Well, theoretically they could, and that could be how our solar system was formed, because we look at the rings of these larger planets that have rings, and the dust, and would they be able to collect and form moons and satellites? So yes, you could say that, this is how our sun became and how the planets in our solar system were created. Now we move on from here. We move into talking about the sun. And the sun, it contains 99% of our solar system's mass. The sun's energy is created by nuclear fusion, mainly the burning of hydrogen. And if we take a look at this image here, we can kind of see a few things. As it burns hydrogen, it's in this first phase. Then we start seeing the burning of the helium, and then the helium force. So we can see that this star, this sun, is really just burning. It's burning helium, or burning hydrogen, and as soon as it gets to the point of burning that helium, it's going to start dwindling down and dying according to our life cycle of the stars. Next lecture, we are probably going to be talking more about the moon, our very own satellite, and talking about some other interesting theories, such as the end of the universe as well.